Hi everyone, welcome back to Geeks for Geeks. So today we are going to discuss about the Job-A-Thon contest, and here we have the first question. So the first question name is minimize the number. So let's quickly have a look on the problem statement. So our problem statement says that given an array ARR of positive integers having size n. Okay, so we are given an array whose name is ARR and we are given the size as n. Find the minimum positive number x such that x modulo array of I is same, not necessarily equal to x. Okay, so we have to find such value of x for that x modulo array of I is same for all of the array elements. So let's see in the example number 1. So we are given n equals to 5 and array equals to 7, 10, 4, 3, 15. So we can easily observe that if I try to take modulo 1 modulo 7, then it will be 1 because it gives the remainder. So if I try to divide 1 by 7, then it will give me 1. So now let's try to find out 1 modulo 10. It will again give me 1. Also 1 modulo 4. So 1 modulo 4 is also 4. 1 modulo 4 is also 1. So 1 modulo 4 is 1. Now 1 modulo 3 is also 1. And 1 modulo 4 15 is also 1, right? So as we can see that all the values are coming to be same, like 1 1 1. So we can say that 1 can be the possible answer for this array. So we have to find out the minimum. So we can see that we can also say that 1 is the answer for this given array. So now let's have a look on the example number 2 as well. So example number 2 given to us is 2 comma 2. Okay, so let us try to find out the answer for this. So we can see that 1 modulo 2 is also 1 and again 1 modulo 2 is also 1. So we can see that 1 and 1 are equal. So we can say that 1 can be the answer for this particular array. So we have observed one thing here, that if I can take 1 as my answer for the given array, and if and only if when 1 is not present in my array, 1 is not present in my array, 1 is not present in my array. Okay, so let's take an example where 1 is also present in my array. So for example, like 1 2 3. So can I take 1 here as my answer? No, because 1, let us try to find out the answer for x value as 1. So 1 modulo 2 is 1. 1 modulo 1, what is 1 modulo 1? So it will give me the remainder. So we can divide 1 by 1. So it will give me 0. And again 1 modulo 3 is 1. So we can see that the values are not coming to be same. It has 0. The value here is 1. Here is 1. And here it is different. So 1 is not my answer. So we have to find out such minimum value so that it follows this equation: x modulo array of I should be same for every element of my array. So how can we find out the element? Now coming to the solution part. Okay, so we can see that I have to find out some number whose modulo comes out to be same. So can we say that, can I find out the LCM of all these numbers? Because if I find out the LCM, so they will be divisible, and they will be divisible. Also, the modulo will come out to be same. That is 0. The modulo will come out to be 0. Here, what is the LCM of 2 comma 1 comma 2 comma 3? So we can see that LCM of 1 comma 2 comma 3 is 6, right? So now let's try to find out the value of the modulos with the array element. So 6 modulo 1, what will be the value of 6 modulo 1? So it will be 0, right? Because the remainder will be 0. Also 6 modulo 2, what is the value of 6 modulo 2? It will be also 0 because it is divisible. Again 6 modulo 3, so what will be the value of 6 modulo 3? It will be again 0. So as you can see that after taking x as equal x as 6, I am getting the uh, modulo values as 0. It is same, right? So we have to find out the LCM of all the numbers which is given into array. So how we can like proceed with the coding part? So one is present, if one is present, then we have to find out the LCM. So return LCM of array. LCM of array. Else, if one is not present, then we can simply say that answer will be one, because after taking modulo of 1 with every other element of my array, it will give me 1. That will be same for every other element of my array. So let's proceed with the coding part. So as we can see that at line 13, I am taking one integer named as L, and it is initially assigned to array of 0. So basically we are using this variable just to find out the smallest value in the array. So we are running, or we are iterating on my given array, and I am finding what is the minimum value of my array. So if at line 16 we are seeing that if L is greater than 1. What does this line say? So it says that minimum value is greater than 1. It means that 1 is not present in my array. When 1 is not present in my array, so what should I return? So from this thing, we can see that I have to return 1 directly if 1 is not present in my array. So I have to return 1 if 1 is not present. So I am returning 1 at line 17. Now at line 18, I am taking one answer variable, and then I am iterating on my array, and then I am finding the GCD. So why we are finding out the GCD? So as we know that GCD of a comma b into LCM of a comma b equals to a into b, right? So how can we find out the LCM of a comma b? So LCM of a comma b will come out to be a into b divided by GCD of a comma b. From this equation, I can find out the LCM. So we can so we are doing the same thing here. So we are finding the GCD of answer and array of I. What is answer? So we are considering answer here as A and array of I here as B. So we are finding out the GCD of A comma B, and then we are multiplying answer into answer array of I. Why we are doing this? To find out the value of A cross B. So answer is A, so this is my answer, and what is B? So B is array of I. So we are just multiplying and storing that in my answer variable, and in the end I am just dividing that answer with my GCD. So I am finding out the LCM by this thing. So A into B divided by GCD of A comma B. So we will iterate over all the array, and we will find out the LCM of all the elements of my given array, and in the end I will just return the answer. So let's try to compile and run this code. So yeah, it's passing on the visible test cases. So now let's try to submit this problem. So yeah, it is passing for the visible. So yeah, it is passing for the hidden test cases also. So I hope you have got the solution for this problem. Okay, so now let's move to the second question, which is named as good subarrays. So let's quickly have a look on the problem statement. So problem statement says that a subarray is considered good if the XOR of its elements is odd and its length is even. So we are given the definition of subarray. It is called good when the XOR of its element is odd and length is even, right? So given an array ARR of length n, return the number of good subarrays. So we just have to find out what are the numbers of good subarrays present in the given array. So let's see what is given. So this is our question number 2, and we have to count the number of good subarrays. Count good subarrays. So we have to count the good subarrays. What is a good subarray? So good subarray is a subarray whose length is odd, whose length is even. Good subarray condition. So good subarray is whose length is even. So the length of my subarray should be even. And what will be the XOR value of all the elements including of that subarray? So what will be the value of the XOR? So XOR should be odd of all the elements. So these are the two conditions which I have to follow to make my subarray as good, and I have to count the number of good subarrays present in the given array. So let us have a look on the example number 2. So we are given example number 2 as n is my 5, and array is given as 4, 2, 3, 2, 1. Right. Array is given as 4, 3, 2, 2, 4, 2, 3, 2, 1, and we have indexes 0, 1, 2, 3, 4. Right. So the number of good subarrays are 4 here. What are these subarrays? So let's try to write good subarrays. Good subarrays. So what are the given good subarrays? So which we are given 1, 4, 2, 3, 2. So this is the first good subarray. What is the second good subarray? So 2 and 3 is the second good subarray. 3 comma 2 is the third good subarray, and 2 comma 1 is the fourth good subarray. Right. So let's try to find out if they are following the condition for my good subarray. So these are the two conditions that they should follow. Length should be even and XOR value should be odd. So we can see that they have all the subarrays have even length. So the length here is 4, so which is even. Length here is 2, which is also even. Here length is 2, and the last one is also having the 2 length. So let's try to find out the XOR values. So XOR values will be something like XOR value of 4 XOR 2 XOR 3 XOR 2 is 7, which is odd. So it is following the given condition for my good subarray. Now what is the XOR value of 2 XOR 3? So 2 XOR 3 will be, 2 XOR 3 will be 1, and it is also odd, so we will mark it as a good subarray. And 3 XOR 2 will be also 1, so we can mark it as odd. And 2 XOR 1 is 3, so it is also odd, so we can mark it as good subarray. So as we can see that these four subarrays are following the properties for my good subarray, so we can consider these subarrays as a good subarray. They are following the same properties. So now let's try to understand the solution for this problem. So what can be the brute force approach? So the brute force approach is that we can find out, or like we can generate all the possible subarrays of even length, and I can find out the length as even, generate all the possible subarrays, and try to find out the even length subarrays from all the possible subarrays, even length subarrays, and then try to find out the XOR values. So if the XOR value is odd, then only I can say that the given subarray is good subarray. But this solution will have like high time complexity, because as we can see that the constraints are very high, so they are 10 to the power 5, n is less than equals to 10 to the power 5, so we have to think something linear. So we have to optimize this solution. So how we can optimize this? So we will try to use the properties of XORs. Okay, so we will use the properties of XOR. So what is the first property of XOR? So if I have an even number, and if I try to XOR that even number with some even number, so it will always give me even number. So this is the first property. And now let's move to the second property. So what is the second property? Second property is that if I try to take even number and it's XOR with odd number, so it will give me the odd value, right? Now what is the third property? So if I try to take odd XOR odd, so what it will give me? So it will give me even value. So these are the properties which we are going to use here in this problem, and we will be using some prefix XOR technique. We will take some cumulative XOR, and then we will try to find out how many good subarrays are there in the problem. Okay, so we will be using these three properties of my XOR. So now let's move to the step number 1 of the solution. So what is the step number 1? So we will find out how many total, or like how many possible subarrays of even length are there for the given value of n. So what is the step 1? So step 1 is find out the total subarray of even length. So how we can find out the total subarrays of even length? So let's see by taking an example. So if I have been given n as 6, let's consider 1, 2, 3, 4, 5, and 6. So we are given these values. So till n equals to 6, what are the possible even lengths? So I have three possible even lengths. So one is 2, second one is 4, and the third one is 6, right? So I can have one subarray of 2 lengths, I can have a subarray of 4 lengths, and I can have a subarray of 6 lengths. So these are the three possible subarrays. So let's try to find out how many subarrays have a size 2. So I can see that this one is of 2 size, this one is of 2 size, this one is of also 2 size, this one and this one. So we can see that there are 5 subarrays of 2 size. Okay, so now let's try to find out how many subarrays are there of length 4. So we can see that this is the one subarray with length 4. This is the second subarray of length 4, and this is the third subarray of length 4, right? So we have three subarray of 4 size. Okay, so now let's try to find out how many subarrays are there of size 6. So I only have one subarray, which is the whole array. I can consider this whole array as a subarray of size 6. So we have one subarray of 6 size. So how many total subarrays are there? So there are total 9 subarrays of even length. So how we can generalize this thing? And if I have to find out the given value, if I have to find out the number of even length subarrays, then how can I find out? So we will be using this formula, which is n minus l plus 1. So what is this? We will be using this formula n minus l plus 1. So we will be iterating from my for my array from so we will be iterating from I value as 2, which is the first possible sub even length, and we will be moving till the value n, and we will try to find out how many subarrays are there for possible value of I. So I will add that number into my sum variable. So we are considering this sum variable as it will keep the track of all the subarrays of even length. So let's take an example for n equals to 5, right? And my I will be increased by 2 at every time in this given for loop. So when I value is 2, so what will be the value of this thing? So this value will be like 5 minus 2 plus 1. So the value will be 5 minus 2 plus 1, which is 4. So I will add 4 into my sum variable. So sum was initially 0. So sum will be increased by 4. Now I have increased my I value by 2, so I will become 4. So what will be the value of this? So it will be 5 minus 4 plus 1. So what is the value? So 5 minus 4 is 1 plus 1, so it will be 2. So I will add 2 into my answer, so it will become 6. 4 plus 2 will become 6. So after that I value becomes 6, so it will become greater, so my for loop will be finished, and in the sum variable I will have the total number of even length subarrays. So let's try to confirm, or like try to see if there are 6 subarrays or not. So let's take 1 2 3 4 5. So this is my array, and how many two size subarrays are there and how many four size subarray are there? So we can see this is this one, first, second, third, fourth. So there are four size subarrays. So we can see that there are four subarrays of size 2. Now let's try to find out how many subarrays are there of size 4. So we can see that this is one subarray with size 4, and this is the second subarray with size 4. So we can say that there are two subarrays of size 4, and by the formula we also got this number of subarrays as 2. So the overall subarrays are there are 6 overall subarrays. So we can see that, okay, so that's how we will get the total number of subarrays with even length. So my sum variable will be storing total number of subarrays, with even length. In this even length, so what was the second condition? Though the second condition was that the XOR should be odd. So from all these total number of subarrays, I will have two cases. So first case is that XOR will be odd. One case will be the XOR will be odd, and what can be the second case? So the second case will be the XOR will be even. So how can I find out this odd XOR possible subarrays? So can I do this thing? So some in my sum variable I have total number of subarrays. So can I find out how many subarrays are there with even XOR values and then subtract these even XOR values subarray from my total number of subarrays. So let's consider the value of the number of even XOR subarrays is X, and the total number of subarrays is stored in my sum variable. So what will be the resultant? So sum minus X, this will be the total number of subarrays with odd XOR. So this will be the answer. So we are going to find out how many even length subarrays are having even XOR. So we can see in our solution also. So by first of all we are running a for loop from I equals to 2, and we are finding out how many possible subarrays are there for each even length, and we are just adding them into my sum variable. After that I am taking one long a variable, and what is this a variable will store? So this will store the total number of subarrays who are starting from my even position and have the XOR value as odd, not odd, have the XOR value as even. Okay, so for now, consider them as a black box. You will just call them and they will return the total number of subarrays which are having XOR value as even. Also, at line 34, I am having one long b variable, and this variable will be storing that how many subarrays are there which are starting from my odd indexes or odd position and having XOR value as even. So as of now, you should consider them as a black box. So you will pass some them value and they will return you some value. So in the end, at line 36, I am just returning sum minus a minus b. So what is this sum variable? So sum is storing the total number or the total count of the subarrays with even length. And what is this a? So a is storing the total count of subarrays with even XOR. And what is this b value is storing? So b value is also storing the total number of count, the total number of subarrays whose XOR value is even and they are starting from odd position, right? So that's how we will try to find out the total number of subarrays which are good. So let's try to see how our even position function is implemented, right? So we have taken the even position function, and here we will be using the same properties that we have discussed earlier, that even XOR even will give you even value, even XOR odd will give you odd value, and odd XOR odd will give you even value. So we will be using these property of XOR in this long even position function. So initially we have one answer variable. So answer is will be storing the number of subarrays with XOR value as even, and at the next thing I have one integer frequency array, and the size of my frequency array is 2. So what does frequency of 0 will store? So frequency of 0 will store the count of even XORs that we have encountered till that index. And what does frequency of 1 will be storing? So frequency of 1 will store count of odd XOR value that we have encountered. Okay, so I have this frequency array with size 2, and after that I am taking one variable which is named as XOR. So what does this XOR will be storing? So it will store the, we can say that it will store the prefix XOR of the values. So we will be using prefix XOR technique here, prefix XOR. So we are running a for loop, and we are starting from I equals to 0 and we are running till I is less than n, and every time we are doing I plus plus. So we are just doing the XOR value. So XOR will be storing the prefix XOR. So I am just doing XOR of the current value with the XOR of my XOR variable, and okay. So what does this if I and 1 condition says? So if I and 1 comes out to be 0, it means that I given to us is even. This is kind of bit manipulation that to find. if you want to find out the number is even or not, so just try to do I and 1, means I is the number. So if this value comes out to be 1, then you can say that, or if this value comes out to be greater than 1, then you can say that the value of I is odd, and if the value comes out to be 0, then you can say that the value is even. So here we are just skipping the even values. So why we are skipping the even values? Let us see. So our function is finding out the total number of subarrays who are starting from even positions, and we only have to find out the even length subarray. So if my subarray is starting from even position, for example, if my subarray is starting from 2, which is even, so what will be the, so if I want to add my current subarray with some even length, so what will be the last index for that subarray? So that will be odd index, right? So for example here 2 3 4 5, so we can see that 2 3 4 5 has a length of 4, length is 4 of this. So I am starting from even position, then I am skipping the even positions. Why I am skipping the even positions? Because if I if I try to find the answer for even positions also, then the length of my subarray will be odd. So I don't have to find out the subarrays whose length is odd. I am only focusing on finding the value for my even subarrays. That's why I'm skipping the even values, and I'm only finding out the answer for the odd values. We were starting from even values, right? So that's why this if condition is used. Okay. Now what is this condition says? So if XOR is even, then what we are doing here? So if XOR is even, so let's say this was your subarray, and at this point you are at the ith index, and this at this point the XOR value comes out to be even. So what was your main motive of this even position function? So the main motive of this even position function to find out the subarrays whose length is even, and also the XOR is also even, right? So you have find out one subarray with even XOR. So you will add +1 to your answer because you have just find out one subarray of that even value. So we are doing +1 for this even XOR subarray, because from the starting value, whichever is the starting point of your subarray, and from that starting point till the current index, the XOR value comes out to be even, then you can say that the subarray from the starting to the current index has XOR value as even, and I will count that into my answer because I am finding out the subarrays whose XOR value is even. Okay, so that's why we are adding a +1. And what is this frequency of 0? So frequency of 0 is tracking the count of even XOR's value. So why we are adding even XOR's value, right? So we are using this property that even XOR even. Frequency of 0 is tracking the or keeping the track of the odd. Frequency of 0 is keeping the track of the even subarrays, and I have encountered one subarray, that is the current subarray with even XOR. I can extend those number of previous subarrays with the current subarray so that the overall XOR will come out to be even. I can say, right? So that's why I am adding frequency of 0 to my answer, because I can extend some previous subarrays whose XOR value was even. So even XOR even is also even. So I can extend those previous XOR values or previous XOR subarrays, and the overall number of subarrays will be frequency of 0, which is the previous subarray, and adding +1 because of the current subarray. So if the XOR value comes out to be 0 or XOR value comes out to be even, then I am just adding the previous number of subarrays whose XOR value was even, and I can extend those previous subarrays with the current subarray. Okay, so this was the if condition for XOR value if it is even. So let's move to the else part. So when it is odd, so if XOR value is odd, so XOR mod 2 will be equals to 1, right? So we will be using this property, which is odd XOR odd. So also when the XOR value was even, then we were just doing frequency of 0 plus 1 plus plus, because frequency of 0 is storing or keeping the track of the even XOR value. So we are just doing frequency of 0 plus 1. Now coming to the else part. So if the XOR value comes out to be odd, then we are adding the previous number of subarrays whose XOR value was odd, because we are utilizing this property of my XOR value, that odd XOR and XOR odd XOR add odd XOR odd will give me even value, and we are finding how many number of subarrays are there with even length and even XOR value. So I can just simply say that if I have two XOR value with odd value, I can just simply say that if I have two XORs with odd values, so I can just simply extend the previous XOR subarray with the current subarray to make the overall answer or overall subarray as even, right? That's why we are not adding a plus one here, because my current subarray, let's say I am here at the index I. So till index I, XOR value comes out to be odd. In the even case, I was adding a plus one because from the starting to the current index, I have got one subarray with even XOR value. But here from the start value to the current value, I have got this subarray with odd XOR value. But I don't have to count the odd XOR value, I just have to count the even XOR value. So that's why I am not adding a plus one at in here. I am just adding the previous number of subarrays whose value of XOR was odd, and those subarrays will extend or can be extended with the current subarray to make the overall subarray XOR value as even. That's why we are not adding a plus 1. And after that, we are doing frequency of 1 as plus plus, because frequency of 1 is keeping the track of the XOR values we have encountered, and the value is odd. And simply we will iterate over the whole array by using this for loop, and in the end we will just simply return the answer. So our even position function is returning the number of subarrays with even length, and they have the XOR value as even, and they are starting from some even position, and they are ending and they are ending at some odd position, so that the overall length of that particular subarray should be even. So this is the even position subarray, and with the same logic we have implemented our odd position subarray, odd position function also. So with the same logic we are implementing our odd position function also. So what does this odd position function will return me? So it will return the number of subarrays with even length and that have the XOR value as even, but they are starting from some odd position and they are ending at some even position. Why so? Because if they are starting from some odd position, so what will be the value for the last index, so that the overall length becomes even? So the last index of that subarray should be even. For example, if I am starting from if I starting my array from 3 and I'm ending at index 6, so there will be the length will be even, right? So we can see that here the length is even. So this odd position function will return me this thing. In the end, what we are doing, we are just doing sum minus a minus b. So from the overall subarrays, so sum stores the overall subarrays, right? Sum stores the overall subarrays which are of even length. I am just subtracting the even position and the odd position number of subarrays. I am storing even position in some a variable and odd position in some b variable, and I am just subtracting a and B from the overall subarrays. So what is A? So it is the number of subarrays with even length and have the XOR values as even, and they are starting from some even position. And what this B value is? B value is the number of subarrays that are starting from some odd position, ending at some even position, and have the value of XOR as even. And the overall, the length of the subarrays is even. So if I subtract this from the overall subarrays, then I will get the number of subarrays. If from all the subarrays, I am just subtracting the subarrays with even value XOR. So I will get the number of subarrays with even length and having the XOR value as well. So I hope this solution is clear to you. Let's try to compile and run the code. So yeah, it's passing on the visible test cases. So now let's try to submit the code. Okay, so it is passing on the hidden test cases also. So I hope the solution for this problem is clear to you. Okay, so now let's move to the next problem, which is named as max student. So let's read the problem statement. There are n students in Geekland numbered from 1 to n and m school numbered from 1 to m. Okay, so we are given like some students whose numbered are from 1 to n, and we are also given m schools numbered from 1 to m. We are given an array era whose length is n, which represents that ith student belongs to array of I school initially. So basically we are also given one array, and this array tells us that which student belongs to which school initially. We are given an integer array strength of the length n, where strength of I represents the strength of the ith student. So we are also given one strength named array. And what does strength of I denote? So strength of I denotes the strength of the ith student. So we are given students 1 to n students. So we are given 1 to n students, 1 to n students. Also we are given 1 to m schools. What is the third thing we are given? So we are also given one array ARR. So what does array ARR state? So it states that ith student belongs to which school initially. So ith student belongs to array of I school initially. And after that we are given one strength array. So what does this strength array denotes? So ith strength. Okay, so strength of I denotes the strength of the ith student. Okay. Now we are given an 2D integer array transfer. So after that we are also given one 2 after that we are also given one 2D integer array, 2D array named as transfers. Okay, so the length of that transfers array is q, where transfer of I denotes the child of I, comma school of I, means that after the ith transfer, child of I belongs to the school of I. So transfer of I, what is transfer of I equals to? So after the ith transfer, this child of I has now transferred to this school of I. So it's given that after this transfer, the child of I will be transferred to the school of I. And after each transfer, we calculate the oddness of each school and return the maximum oddness among all schools. So after, for example, after the first transfer, so we calculate the oddness. So what is oddness? What is the definition of oddness? So oddness means oddness of a school is defined as the minimum strength of all the students studying in that class. So what is oddness? So oddness is the minimum strength of all the school from all the students of that particular school. And after each transfer, we calculate the oddness of each school and return the maximum oddness from all of them. So suppose we have three schools. So first school has oddness of 2, second school has oddness of 1, and third school has oddness of 4. So what is the maximum oddness of all these schools? So 4 is the maximum oddness. So we have to find out this maximum oddness after each transfer. Okay, so let's look at the example number 1. And also, transfers should be performed in same order as given. So we cannot do like this, that we are first transferring the student which is present at the second index, and then we are transferring the student present at the first index. So we have to follow the same order which is given to us in the transfer array. If school has no student, then its oddness is considered as 0. So if there is no student in that particular school, so we have to consider that the oddness of that particular school is 0. Okay, so now let us have a look on the example number 1. That will be helpful for us to understand the question. Okay, so we are given 1 to 3 students, 1 to 3 students, and we are also given 1 to m schools. And what is the value of m? That is 3. And after that we are given value of q as 2. It means that the length of my transfer array is 2. And we are given array as 1 2 3. So array is given as 1 2 3. It means that the first student belongs to the first school, the second student belongs to the second school, the third student belongs to the third school initially. So let us write here. So this is my ARR, which will be storing the value of the school for that particular student initially. After that, I am given one strength array. So what does this strength array store? So it stores the strength of that ith student. So 1 3 4. It means that the first student has strength 1. It means that the second student has 3 as a strength, and third student has 4 as a strength. So this is our strength array. After that we are given transfer array, and what is the zeroth element of the transfer array? So zeroth element of the transfer array is 1 comma 3. It means that the child whose school is 1. Okay, so we are given at the zeroth index, we are given 1 comma 3. So what does this 1 comma 3 denote? It denotes that the first child is now transferred to the third school. Previously, what was the school of the first child? We can see from the ARR array that first child belongs to the first school initially, but after the first transfer, what is the configuration, or like how are my schools look like after the transfer? So the first school will become empty. So first school will become empty. And what about the second school? Second school has second student. And what about the third school? So third school will have first student and third student. So this is the configuration of my schools after the first transfer. So this is the first transfer, right? So now we have to calculate the oddness. So for the first school, what is the oddness? So we can see that there is no student in the first school. So the oddness is 0 as it's given in the problem statement. So oddness here will be 0. Now coming to the second school. So what is the second school oddness? We can see that in second school I have the second student. So try to find out what is the strength of the second student. So we can see that second student strength is 3. So oddness will be 3 for this. And what about the third school? So we have 1 and 3 in our third school. So what is the oddness of first student, or what is the strength of the first student? So the strength of the first student is 1. So let's write 1 here. And what is the strength of the third student? So from strength array we can see that 4 is the strength of the we can see that 4 is the strength of the third student. Now for each school, how do we calculate the oddness? So for each school, from all the strengths I have to keep the minimum strength. So from the first school, so we only have one oddness, that is 0. So we will only consider that, and for same for the second school. Now for the third school, we can see that we have two values. So which is 1 and 4. So which I should take? So I should take the minimum one because it's given in the problem statement. So I will take the minimum one, that is 1. Now from all these values, I have to find out what is the maximum value. So from 0, 3, 1, what is the maximum value? We can clearly see that third is the maximum value. So that's why after the first transfer, my output array having 3 at the first index, right? So this is the configuration of the schools after the first transfer. Now let's see what is the second transfer. So the second transfer looks like 3, 1. It means that the third student is now transferred to the first school. So how will be the configuration of the school? So first school will have 3 because third student is now transferred to the first school, and second will have the second student, and third school will have the first student. Okay, now let's talk about the second transfer. So we can see that third child is transferred to the first school. So this will be the configuration of my schools. So first school will have the third child, and second school will have the second student, or the third school will have the first student, right? So now find out the oddness value. So how will we find out the oddness value? So we only have 3. So what is the strength of the third child? So third student. So the strength of third student is 4. So we will write 4. Now what is the strength of the second student? So the strength of the second student is 3. So we will write 3. And what is the strength of the first student? So the strength of the first student is 1. So I have got the oddness of all the schools. So from all these schools, I have to find out what is the maximum value. So what is the maximum value? So we can see that 4 is the maximum value, right? So that's why answer for the second transfer is 4. So 3, 4 is the answer for this given example. So this was the problem statement. Now let's understand the explanation also. So in the explanation, it says that after first transfer, school 2 belongs to after first transfer, student 2 belongs to school 2. We can see that student 2 belongs to school 2, and student 1, 3 belongs to school 3. Yeah, we can see that student 1, 3 belongs to school 3. Now oddness of school 1 is 0. Yeah, yes, we have oddness as 0 as no student. And oddness of school 2, what is the oddness of school 2? It is 3. We can see that oddness of school 2 is 3. And what is the oddness of school 3? So it will be the minimum of 1, 3. So it will be 1. So from all these 0, 3, 1, so 3 is the result after first transfer. Similarly, after second transfer happens, student 1 belongs to school 3. We can see that student 1 belongs to school 3. This, and student 2 belongs to school 2. School 2, we can see that student 2 belongs to school 2. And also student 3 belongs to school 1. So we can see that student 3 belongs to school 1. Now oddness of school 1 to 3 are 4, 3, 1. We can see that oddness is 4 and 3 and 1. And from all these values, I have to select the maximum value. So 4 is the maximum value. That's why answer for our second transfer is 4. I hope you got the problem statement and the explanation for the example. Now let us have a look on the approach part. So how can we approach this problem? Okay, so what can be the approach here? So if we try to do the brute thing, that doing the same thing which is given to us in the problem statement, then that solution will lead to TLE because of the higher constraints. So we have to think of the optimized approach. So how can we think of the optimized approach, right? So the first thing that we have to notice is that after the transfer, only two schools are affected, right? After transfer, after the transfer, only two schools are affected. What are these two schools? So the first school is that in which the child is transferred. So the first school is that one, child is transferred. Child or student that is transferred. And what is the second? what will be the second school? So the second school will be the from which school that child is being transferred. So for example, if we consider that the student 1 initially belongs to school 2, but after the transfer student 1 now belongs to school 3, right? So after we can see that before the transfer my school 2 will have student 1 and school 3 will not have any student, but after the transfer my school 2 will not have any student and school 3 will have one student. So we can observe one thing, that only after the transfer only two schools are affected. So we will take the advantage of this fact and we will try to reduce our number of operations to calculate for every school, right? So okay, so let us look how we can approach this problem. So first of all, we will made one data structure which is named as A. So what does this data structure will store? So it will store the strength of the school, or not the school, it will store the strength of the student, and also it will store the school of the student initially. So it will store, we can say that it will store my pair, and what will be the value of pair? So it will store the strength and school. So we have made one data structure A, and it will store strength of the school, strength of the student, and the school of the student, right? After that we have made one vector of int, and vector int res. So it will store the result, that is the final answer we have to return. And we also make one oddness named array. What does this oddness will store? So it will store the oddness of all the m schools initially. So it will store the oddness of all the m schools initially. For example, 0, 1, 2, 3, 4, and the name is oddness of that array. M plus 1 is the size. It will store the oddness of all the schools initially. After that, I am making one vector of set named as lib. So what does this lib will store? So it will store the number of students which are present at that particular school. For example, that if I have school number as 2, so it will store what are the students which are currently in my school number 2. So it can be 1, 3, 4, like this. So lib will store the number of students at the particular school. Okay, now after that we have made one vector of priority queue, and the name of that vector is school. So we have made one m plus 1 size vector of priority queue. Now we are just iterating from 0 to n, and what are we trying to find out? So at the very first value we are trying to find out the strength of the ith student. So strength underscore I is storing the strength of the ith student, and we are finding out the school of the ith student from the array of I, and we are just doing we are just modifying that school as zero based indexing, because we are given as one based indexing in our problem statement. So we are just modifying. How we are modifying? We are doing minus 1 in the array of I. Okay, so the school value will become as the zero based indexing. Now at the next line, what we are doing, we are just pushing the strength of the ith student and the school of the ith student, as we have discussed earlier. This A data structure will store the strength of the ith student and the school of the ith student. And after that, what we are doing? So we are just pushing or inserting the ith index, ith value in my lib of school of I. It means that second student, what are the number of, or what are the indexes of the students which are in this second school? So this line will store that value. For example, the third child is in the second school, so it will push second, it will push the 3 into my second index. And also we are using set here, so it will only store the unique value, so it will store 3 here. Suppose at the next iteration uh, 4 comes up here, and 4 also says that my school was 2, so 4 will also be pushed into that set which is at the second index of my lib vector. Okay, now after this what I am doing here, so I am just doing school of I. So this school of this school is my vector. So suppose this is my vector, and at every vector I have one min heap. At every index I have one min heap. So at this line school of I dot push strength underscore I comma I. So what does this line do? So it is storing the strength and I as a pair of my school. So school is my main heap, and at every index I am storing the school of I. So means at every index of the school I have the number of, it means that at every index I am storing one min heap. So what does this min heap will give me? So this min heap will give me the minimum oddness of all the students from that particular school. For example, if I have like 2 and the student was 1, and like 3 and the student was 2, so at min heap 2 will be at the very first, because we need the minimum oddness from all the students, right? Minimum strength from all the students strength, that is the oddness, right? So that's why we are taking one min heap in every school. At every school we are taking one min heap, so that I can easily find out what is the oddness or what is the minimum strength of all the students. So after that what I am doing, I am just updating the oddness value. So how can I update this oddness value? So I am just finding out what is the top of that particular school. So by this line from top till top, so what I will get, I will get the strength of the student and the student at the top of that school array. So what I will get from this line, oddness of school of I equals to school of school I dot top. So from till this point I will get what is the strength at the top of the min heap, and what is the child or the student id which is at the top. So from this line I will get the minimum value, like I will get y pair. So for example, in this given example I will get 2 comma 1, right? So from this 2 comma 1 I need the minimum strength. So how will I get the minimum strength? So I will take out the 0th element, and this is first element, right? So I will take out the 0th element. So by taking out the 0th element I will get the minimum value or the minimum strength from that particular school. So I'm storing that value in my oddness array, because this oddness array is keeping the track of the oddness of every school from 1 to m. Okay, so what I will do after this? So now, okay, so after this I need to find out the maximum value from all these oddness. So what I am doing here, I am making one priority queue named as answer. So this is min heap, and I am pushing all the oddness value which are greater than 0, and I am pushing the oddness and the ith index, means the school at which the oddness is oddness of I. So I am making one min heap, and I am just doing answer dot push, and I am just doing a pair, pushing a pair, oddness of I, and the index also. So this min heap will give me the maximum value from all the oddness, because I need the maximum value from all the oddness, right? So I am taking, that's why I am taking my answer max heap to find out this maximum value. Okay. Okay, so till this point we are done with the initial setup. So now we will try to transfer student from one school to some another school. Okay, so now let us see how we can transfer. So we will only change the or or so in this thing only two schools will be affected as we have discussed earlier. So we will only try to affect only two schools. So how we can try to find out? So we are iterating on the transverse array from j equals to 0 to q. So I am iterating from my transfer array, and what is the value of c here? So we can see that c equals to transfer of j comma 0. So we are trying to find out what is the student id of that transfer array. So c will store the student id as zero based indexing. So we can see that c will store the student id. And what is the value of d? So d values transfers of j comma 1 minus 1. So it will be the school or the new school in which the c student, that is student id, will be, that is the student id will be transferred. So d, we can say that d is the school or the new school. We have just find out the what is the student id of the current what is the student id and what is the new school of the current student. Okay, so after this we will try to find out what was the old school of this current student. So how we can find out? So as we have used our data structure, which was it, as we can see previously, we were making our data structure, and what were the values stored in my data structure? So strength comma school. So our data structure stores this thing, strength comma school. So how can I find out the old school from this current student ID? So I can just simply do B equals to A of C. So what is the C? So C is the student ID, and I need the second thing, which is the, what is the first index? So first index is the school. And what is the zeroth index? So zeroth index is the strength. But I only want to find out what is the uh, previous school of this current child. So I can just simply find out this by doing b equals to a of c comma 1. So this will give me the old school of the current student, because I have to update these two schools, right? I have to update old school and I have to update the new school. I just only have to update these two schools. So now how can I update? So first of all, I will say that lib of b dot erase c. So why we are taking this line? So we can see that our lib array, what was lib array was storing. So lib array was storing what are the number of students at that particular school. So as we can see that the C student is now transferred to school D. So we have to update this old school, right? So lib was storing at B index. My C student was previously stored, right? Because C was previously in my B school. But now we have to remove this. Child from my previous lib array. So how can I remove this? So I will just simply go on the lib of B. So I will simply go on that index. I will erase C from that current index, right? So lib of b dot erase, this will erase or remove the c student from school D. Okay, and after that what we are doing? So we have to update the min heap also, because at because the school, what was the school was storing? So school was storing the min heap for every school, the minip for every school. So school was storing the minip for every school, right? Now the school B has some. Now the student C has left the school B. So I have to update the value of that min heap. So how can I update the value? So I will run a while loop till the school of B dot size. It means that the particular school has the student, and also lib of B dot find school of B dot top of 1 equals to lib of b dot n. So what does this line say? So let us try to write this line. So lib of b. Okay, so till I am getting the minimum. Okay, so till lib of b dot find of school of b dot top of 1. So let us find out what is school of b dot top of 1. So what is this value? So this will be the value of the school, or we can say that school ID. So what is school of B? So school of B will give me the school of B dot top will give me the min heap or the minimum value that is present at that school. So school of B dot top will give me the minimum value, and I am taking the first index value. So what was the first index value that we were storing? As we can see that we are storing the I. So I will give me, what is the I? So it will give me the index of that particular school. So it will give me the school ID. So till that index, or like till I'm not finding that school ID in my lib of B, I am running my while loop, and also the size of a school of B remains greater than 0, right? So I am just popping out what is at the top of that min heap. So this line is also done. Now my while loop is finished. Okay, after that, if after transfer there is still one student in school, then we have to update the oddness of that particular school, right? Because we were keeping the track of oddness in our oddness named array, right? This one. So we have to update that value. So we were keeping the track of our oddness in this oddness named array, and we have to update that value if there is some student left at that particular school. So how we can do? So we will just find out if there is any student, like how can I find out? So school of b dot size is greater than 0. It means that in that particular school I have one student or more than one student. So how will I find out the topmost value? So school of b dot top will give me the topmost value, and I need the oddness or the strength of that school. So how can I get the strength? As I have stored strength comma I in my min heap of that school. So how can I get this strength? So I will find out the 0th element of that particular min heap. So that's why I am doing oddness of b equals to school of b dot top of 0. So this will find out the strength of the minimum strength of all the students which are in that particular school. Also, after the next line, we are just adding that particular oddness in my answer max heap, because it will be storing the maximum oddness. And if I have to find out the maximum oddness, then I can just simply find out from that answer array. Okay. After that, what we are doing? So if there is no student left, so as we have seen in the question statement already, question says that if there is no student, then I have to consider the oddness as 0. So I am just doing oddness of b equals to 0. So after that, now we have updated the old values, right? Now we have to update the new values or the new school values. We have updated the old values. Now we have to update the new school values. So how we can update the new school values? So first thing that we have to do is we have to update our data structure that we have made to store the values of student and friends. So how can I update the school of that particular student? So I can simply do a of c comma 1 equals to d. So previously a of c comma 1 was b, but now it has transferred, or this student has transferred to some d school. So that's why a of c comma 1 equals to d. So the new school is now d. So first thing is done, that we have updated our data structure. Now we are finding out what was the strength of this current, what is the strength of this current child. So we are just storing it in our a variable. How we can find out? So we can just simply find out a of c, and the zeroth value. What is the zeroth value? So the zeroth value is the strength. Zeroth value is the strength. Okay. Now after this, I have to update in my lib also, lib array, because at the DH school I just have got one another student, that is C. So I have to do just simply do lib of D dot insert C, because this C student has now transferred to my school D. Okay, so this thing is also done. Now after this, we will update the school of D priority queue also, because at the DS school I have added that C student, so I have to update this DS school priority queue also. So just do school of D dot push A comma C. What is A? So A is the strength, and what is C? C is the student ID, which is the current student. So school of D school of D school of D dot push A comma C. So it will be pushed as a heap in my min heap, not as a heap. So it will be pushed in my min heap. Okay. Now after this, what we have to do? We are just updating the oddness if after transferring it has changed. So it can be the case like after transferred my C student into the new school, which is the D school. So if after okay, so after the transfer of the D's to so after the transfer of the student C into my school D, so it can be the case that the oddness will be changed. So how can I update the oddness? So in my oddness array, I have stored the oddness of that particular school. So till oddness of D not equals to school of D dot top of 0. It means what is school of D dot top of 0? So it is the strength school of D dot top school of D dot top of 0. So it is the strength which is at the top, which is the minimum strength. So till the oddness is not, if the oddness is not equals to the minimum strength which is at the school of D, so I will update the oddness of that particular school, that this is the new oddness after the updation. Okay. Now after this line, what we are trying to do? So we are just trying to make one score variable which is storing the topmost value, and score variable which is storing the topmost value of my answer max heap. So what is the answer max heap? So answer max heap is storing the maximum oddness of all the schools. So score will be storing the maximum oddness. So answer dot top, and I am only want the strength. So that's why I am taking the zeroth value of the top. Now I am also making one index idx variable which will store the index of that particular school. So how can I get the index? So I can get the index by going at the first index, because I have stored the values like strength comma index, right, in my min heap, in my max heap, which is answer. So to get the values, I can just simply do answer dot top of 0 to get the score, and answer dot top of 1 to get the indexes. Now if the oddness in answer priority queue is not up to date, then we have to repeatedly remove that from my answer priority queue, because after the transfer it can happen that the oddness is not up to date in my answer maxi. So I just have to repeatedly remove and just follow the while loop that we are running, and after this while loop we will get the score. And what is the score variable? Score variable is storing the maximum value or the maximum oddness from all the schools. Okay, so we will just simply push back that maximum score into my res variable or the res vector, and just simply after this for loop, what I will do, I will just simply return my res vector as our answer. Okay, so let's try to compile and run this. Okay, so it's passing the visible test cases. Now let's try to commit the code. Okay, so it's also passing the hidden test cases. So I hope you got the solution, and thank you for watching this video.